Thank you very much.
Sorry, I couldn't hear any of that, so I don't have headphones. But everyone hear me all right? Fortunately, I don't have sunglasses, but those lights are really quite bright, aren't they? But I hear Alien Vault are giving away some pretty funky sunglasses, the green ones, flashing green lights. Loving those. Right, so I'm Tim Holman, and we're here to do a talk about PCI DSS version 3, AppSec and penetration testing, and I'm joined by Adam Brown from Quotient, who's the guy over there. We'll roughly do about 10 minutes each, and then we'll have 5 minutes for questions afterwards. I was about to make some really bad joke about wearing headphones. I'm going to do a head lice as well, but I don't think that'd go down very well, really, would it? There we go. Right, let's get cracking. Right, we're there. So we think web application is still a huge problem. I mean, there's plenty of web application breaches that we hear about in the press. And even the Verizon data breach report still confirms there's almost 4,000 confirmed web app incidents over 2013, and those are just the ones we know about. And it's the usual suspects. We're seeing cross-site scripting, password guessing, SQL injection, but mainly hackers are going after user management systems in order to get in. And we're finding security issues. They're getting found out too late. They're getting found out after the fact. When someone's breached the system and got in, we're finding out the web application's insecure. And normally it's really simple things that haven't been fixed or haven't been addressed that's causing these breaches. I mean things like not changing default passwords or using third-party application libraries and perhaps not tuning them properly. I mean, there's so many simple things that we observe as pen testers that should have been fixed, but they're simply not. And I think there's some reasons for that, and we'll certainly go into that a bit later. And but I'd say on the web app front, most issues are down to really applications not having proper input validation in them. I mean, that's something pretty basic. Make sure you can't put 1,000 characters into a password field, for example. And we're seeing, there's definitely a conscious business decision to push software out. Either businesses don't really know their stuff's insecure or they don't care, but there's stuff out there that shouldn't really be there at all. And that's definitely mirrored by what we do as pen testers. Some of the basic sanity checks aren't being performed, and businesses are kind of oblivious to security in most cases. I expect you hear that in a lot of other talks here today and yesterday, maybe tomorrow. And at the moment, hackers have got free rein. They can cherry pick their targets. They can set up a script to go off and find vulnerabilities, scan 10, 20,000 machines, and then just go after the ones that come up, because they'll always find something. So, as this talk's kind of about PCI. I mean, how many in the audience are responsible for PCI DSS? Do we have any PCI people? That's not bad. Sorry. 3 out of 100 in the PCI talk. I'm liking that. Do you have any developers in the audience or people responsible for managing development teams? That's great. That's bad. And I assume the rest of you got some sort of interest in application security. But if I throw around phrases like cross-site scripting, XSS, CSRF, you won't all leave, will you? We're good. And everyone else is just taking a break, having a seat, or they've got lost or in the wrong theatre. Fair enough. So I'm going to look at PCI DSS version 2 from a QSA's viewpoint. So I still think, from an AppSec point of view, there wasn't really anything wrong with PCI version 2, and PCI 3 changes, as I go into a bit later, they're pretty trivial. So I've been a QSA, PA QSA for about the last 8 or 9 years now. So I've been doing quite a lot of these. So what I'm going to take you through is what the sort of things I'd look for. If I'm auditing a company, assessing it against Section 6 of the PCI standard, which is the one with all the application security bits in, and these are the sort of things we have to look for. So first of all, what I'm looking for is an established SDLC, which is Software Development Lifecycle. So I'm looking for some sort of code review. Every time a developer pushes out a bit of code, I'm looking for somebody else in that organisation to review that bit of code and basically say, yep, that's okay, we can release this to production, or no, it's not. I'm looking for separation of duties. So I want to make sure that the person that develops the code isn't the person checking the code. It might sound pretty obvious, but there's a lot of companies out there might only have one developer and they're doing the whole lot, and that can cause a bit of an issue. I'm looking for the SDLC to follow IAST top 10 or SANS CW top 25 or at least some sort of industry standard around application security. And conversely, I find sometimes businesses don't really know what OWASP is or what SANS is or have any framework, which is a shame. And above all, I'm looking for, an SDLC doesn't have to be complex. I mean, all I'm looking for is, documented, easy to follow procedures, like, develop a bit of code, chuck it in Subversion, get someone else to review it, and tick the box, say they've done it, and push the code out. It's nothing hugely complex. I know there's a lot of SDLC type models out there that are, run into 300 or 400 pages in a document, but it's nothing that complex. If you can get it on a page of A4, I'm more than happy with that. And as long as you can demonstrate you're following it. And then, of course, if you've got a code base that's been around for 7 or 8, say it's been around for 3 or 4 years, and PCI DSS comes along. Now, I'm not just looking for you to review the changes you make to that code base from then on. I actually sort of need some sort of warranty or guarantee that you've actually looked at the whole code base. So since day one, whenever that code base was released. So also in PCI DSS, I'd want to make sure that there's regular developer training. So if you've got a team of developers, then some sort of awareness program carried out at least annually. And I think annually is a bit infrequent. I mean, I'd recommend sort of quarterly. Just to make sure developers are aware of security and know what things like XSS, CSRF and SQLi, and know what all this stuff actually means. And of special interest in audits is, I find there's a lot of trust in third-party libraries. Like, I think developers, if they want to take shortcuts or make life a bit easier, they'll get an off-the-shelf DLL, well, we're not a DLL anymore, but an off-the-shelf package, we call it bloatware, and just stick it in the application and just use 1 or 2 features from that piece of third-party software. And there's always the assumption that, that third-party bit of software is secure, and we often find it's not. You only need to look at OpenSSL and Heartbleed. That's one example. And I'm also looking at, some companies will outsource development. And there's a lot of trust between the business and the outsourcer. They're kind of expecting, well, if we're paying you to develop code, hey, we're paying you to develop secure code, and that's not really the case. And in some cases, I've seen development's been outsourced to certain countries. Certainly the Ukraine, for example, of late, and that's caused some real issues with those developers have had to stop working due to the national crisis out there. And I think continuous security is already implied in version 2. As I said, there's not really much new in version 3. And then the last point on that slide really is I find where there's an annual tick box mentality with PCI DSS. If a company sort of follows that attitude, they often find that their SDLC and all their code reviews are a sort of a once-a-year thing as well, which is a bad thing. I mean, security needs to be, application security needs to be addressed after each and every code change, and certainly just not once a year. It's just not enough. So I'm going to cover off some of the changes in version 3, and as I said, there aren't really that many. There's clarifications, fixing a few typos, spelling mistakes, and I can get it all on one slide, in effect. So PCI DSS, every 3 years it changes, and they like to introduce new things into it just to make sure it's up to date. And one new introduction for PCI 3 this year was more of a focus on in-memory vulnerabilities. So what's the application doing in the memory space? Because I think we found after the Target breach last year that particular vulnerability, well, it wasn't a vulnerability, it's someone getting in and planting malware that just sniffed the card data out of memory. So PCI is asking you to have a little look and be a bit more sensible about what you're doing with data in memory. For example, if you're going to use memory variables, then close them down afterwards. Don't just leave stuff in memory and it ends up in a page file and all sorts of stuff like that. Another inclusion is putting in coding practices to protect about broken auth and session management. Session cookies shouldn't just be n+1. Hope that means something. Yeah, and quite rightly we find that doing our pen test. People have decided to develop their own cookies or session cookies, and they just take a session cookie 1000 and the next one's 1001. Well, that's quite easy to hack, really. So, recommend against that. And of course, there's a pen test methodology mentioned in PCI DSS. But that's really there to make sure you've got a baseline against which you can measure and improve. It's not there to make your life difficult, it's there to help you. And there's some other stuff around checking network segmentation is effective, but as this is sort of more of an AppSec talk, I won't go into that. So I think PCI DSS version 2 is still very effective at securing applications, as long as you follow and understand and implement the guidance correctly. And certainly agile methodologies, I've mentioned that. It's a great opportunity to start looking at continuous code reviews, because you've got an opportunity to do the review after each of every sprint. So my last sort of slide on this before I sort of hand over to Adam really is really sort of convincing the business. I know that's a common trait in a lot of these talks really, is getting buy-in from the board or the company owners to take all this seriously. So, we find that from a business perspective, new code needs to be ready yesterday. Applications, they help businesses make money. The businesses want to push the application out, make a ton of cash, and delays are frowned upon, and they put a lot of pressure on the developers to push out code. And I think somebody somewhere deep down always knows that they're releasing insecure code into the wild, but the business takes a decision to roll that out because they need money to stay afloat. As simple as that. But that also causes issues like bad developers or even outsourcing partners will make mistakes that go unchecked, and that's causing the web application we're seeing in the wild today with all these vulnerabilities that are quite basic. So the way forward really, I know as PCI has been around, it's been telling you to do this for the last sort of 7 or 8 years anyway, and I'm still sort of convincing businesses to do the whole lot properly, but I think as Adam has shown, insecure applications will always, that just cost the business a lot more money in the long run, and there's certainly no excuse for shabby code, and the problem is it's easily fixed by integrating security into your life cycle and getting stuff checked out, and but that's only going to work if you do things properly, and there's certainly no halfway house in security. So that's me done. I was going to pass over to Adam, and he's going to have a quick talk about one way to do this around interactive application security testing. So over to you, Adam.
Thank you very much, Tim, and good afternoon, everybody. I'm Adam Brown. I'm UK manager for Quotium, and what I want to talk to you is about how IAST works and how it can save time and money by addressing application security accurately and often in the application development lifecycle, particularly in the context of PCI. So first of all, I want to identify what is IAST. So the software company I work for used to do a lot of penetration testing, code reviews and application security consulting until we sold the consulting department to a large blue chip organization early last year. So the information I'm going to talk about just now is based on experience. So really you can break down automatic application security testing technology into 3 camps. There's a latest one, which is IAST, Interactive Application Security Testing, of which Quotium are pioneers of. These, incidentally, are acronyms created by Gartner. So there's IAST, then there's DAST and SAST. So Dynamic Application Security Testing, which is black box testing or scanning, and then Static Application Security Testing, which is code review, static analysis. So if we look at what black box testing did for us, we saw that, okay, it's great, you have a black box and it will find some vulnerabilities, but it won't necessarily find them all, and it will find a lot of potential vulnerabilities that may not be exploitable. Now that's not very good for a development team who are hard pushed in a fast-paced, maybe a sprint in an agile process, and they need to get some code delivered within 2 weeks. So the scan will find some vulnerabilities, but it can't give you root cause analysis because by nature it is a black box, so you can't see inside. You're analyzing the behavior of the apparent behavior of an application. So So the other approach is static analysis, where you're kind of going from the inside out. You take an application, you take code, dead code basically, that's not running, and break it down into its component parts. And that automation is looking for theoretical vulnerabilities in the code. So the benefit there is you do get root cause analysis, but you get no kind of evidence of exploit. Now, also, so this is another fundamental issue with static analysis is it can't work very well with MVC, like model view controller applications, and also, as is fundamental to both SAST and DAST, you end up with a lot of noise and false positives. So we moved into creating some software, and there are other IAST solutions, but we created something about 4 or 5 years ago now, which does IAST. And the way that works is it tracks data through the application stack. So if you imagine you have this black box, and then if you kind of run an X-ray through the black box as you're doing your security testing, and you track data, so card holder details, personal account numbers, usernames, passwords, sensitive data, up and down the application stack, also application attacks, and see which code is touching those, so you're doing a runtime analysis, then you'll start to very accurately detect real vulnerabilities, as well as be able to pinpoint the code that is the cause of the vulnerability. So for a development team, that's fantastic, because you can say, here's a real vulnerability, and only a real vulnerability, and here's the code that caused that. So realistically, in the next sprint, or even the next build, you could feasibly reduce that. So let's take a look at an application an application stack. So this is a very generic multi-tier application. We have on the left-hand side the client, maybe a web server, application server, and database all the way down to the back end. So what's happening is sensitive data is being sent from the client to the web server, and then that's passing on either requests or information to the back end, which is comprising of some business functions. Now they could be written by users, so it could be user libraries, it could be, as Tim said, bloatware, off-the-shelf runtime libraries, and they're running on an application server. And that information is being sent to a database. But imagine this scenario. A developer is writing some code and there's a problem with it. So the developer starts to do some debugging and writes everything that code touches out to just a clear text log file. Now, nobody knows about this, and then when we start to promote to a test system or even to a live system, no one's really aware of this. So whether you're doing a scan or just a simple pen test, you may not see that information. Well, you certainly wouldn't see it with a scan. So what we can do by implementing some sensors on all of the layers of the application, so some monitoring going on each tier, we can then track the data. So we can say, okay, we saw a personal account number in the case of a credit card. It made it through encrypted and it was never stored in a decrypted fashion all the way to the back end. And then maybe we went off to a tokenization service or to a database or something like that. But at that point, that code, that personal account number was written to a debug file in clear text. So instantly we can say this page, this control, so perhaps the cardholder data field, that is being written to this clear text file on this server, and it's this code that is doing it, so you can remediate it very quickly. Likewise with usernames and passwords that have to be kept secure, likewise with application attacks. So if we take SQL injection, for example, we can see the attack string. If it's exploitable, we'll see it go all the way to the database and be executed on the database, so you can say without a doubt, SQL injection is happening on this application, and it's this code on this, whatever machine it is, that's causing it. So that would be addressing section 6. Now, it's not really just section 6 that you can address by this kind of analysis. If we look at the PCI DSS directive, okay, so we have to protect cardholder data. So, of course, data can be stored, it just must be rendered unreadable. But by doing runtime code and data analysis, that will tell you if that's actually not happening. again, to encrypt cardholder data over public networks, and more often in the PCI environments I've seen, you also encrypt from tier to tier, because there could be any kind of man-in-the-middle attack somewhere. If that's not happening, but with this kind of analysis, you'll be able to see it very quickly. So requirement 6, this is pretty much the bread and butter of any application security company, and that's obviously really important. And it's, as Tim says, it's not really changed from version 2 to 3, apart from some extra clarifications and some additions of further classifications. But a secure application is vital for data security, which is the PCI DSS standard. Because if you don't have a security standard, a hacker could very easily bypass all of your security controls. Again, requirement 8 to assign a unique ID to each person. That also means that usernames, well, certainly passwords, must be stored encrypted and transmitted encrypted. And if that's not happening in the same way that we can identify cardholder data, we can identify that with credentials. And finally, requirement 11, which is to regularly test security systems and processes, or regularly test the applications. Well, by using an automatic process, that's something that we can easily do. So this becomes almost like, to use a dental analogy if I could, something like cleaning your teeth. And then when you get some really good pen testers, like maybe Tim and his guys, in to do the pen test, they're not finding howling great big holes in your application. It will go through and it's a pen test passed, because a pen test shouldn't really be part of a diagnostics process. So addressing requirement 11 like that actually gives us a business benefit. This is something we can go to the business with and say, we can save money by doing frequent and early testing. So be it agile or waterfall, if you can test the moment that you have a working application, you'll be able to save some money. If we look at this blue line here, the exponential blue line going up there, that is the cost of a bug. This is a Capers-Jones graph. It relates to application quality and, by extension, security bugs. The cost of remediating a software bug after release is far, far higher than the cost of remediating that exact same bug as soon as it's been produced by the coder themselves. If you look at the left part of the graph, most of the bugs are introduced during the coding phase, as you would imagine, and as soon as the application's buildable, we can start to discover them. So that's the best place to do our testing. If we leave it till it's too late, then you have all sorts of issues like other bits of code relying on that piece of code, and then remediation starts to cost a lot of money. Additionally, you have the risk. You may decide to go live with these vulnerabilities, and then you're exposed for that amount of time. So how does this work for agile development? Okay, I'll just do a brief synopsis of agile. Okay, we have a product that we need to create. So that is broken down into its component parts, and we have a product backlog, which is a bunch of requirements. Now, the Scrum, which is a bunch of developers, will go to the product backlog and take what they believe they can produce within a 2 to 4 week period, which is the sprint that they will execute. And that is a process, a 30-day process of regular builds, and in fact many inside here, every few hours there will be a build of some code, and eventually they work through their sprint backlog and produce a working increment of the software. So you can't realistically do a pen test every 2 hours or every day, or you might not even want to do it every week, I should imagine. But by having an accurate process that delivers clear results, like doing this kind of runtime analysis, then we can very quickly produce workable results that developers can work with, which can allow them to create secure code quickly, because usually the priority, as we know, is not security. It's usually functionality, sometimes performance, and putting these requirements in place. And security is something that's kind of, well, we expect it to be secure. So we very rarely get extra time and funds to build security in. So really, that's it from me. Thank you very much for listening. If there's any questions, please let me know. Thank you.